Hi everybody, this is the second part of Properties of Exponents for Math 2A. This lesson was delivered on Thursday, September 9th. So in this lesson, we do a review of the product rule, a review of the quotient division rule, negative exponents, and we see why this works, the negative exponent rule, and then zero as an exponent, see why this works, and then finally some new material, power to a power rule. A reminder for you folks to add yourself to remind.com. Not a lot of you have still, so I need to get you all on there so we can communicate the best for me. And then at the end of this lesson, your homework is to do the first mastery test in Edmentum. So as always, get your paper and pencil out, take notes, copy down what you're seeing, and follow along. You can pause the video and then try it out and then turn it back on to see how you did. So here's the homework problems from the last lesson. In this video, I won't be showing you the answers to this. I want you to work with the tutor Brandon or work with me to go over these. So if you're watching the videos, I want you to try these on your own using what you see in the videos. But reminder, when you're done with your homework assignment, that paper homework assignment is to take a picture of it so you can actually see it, make sure it's a decent picture. If I can't tell what it is, if it's too blurry, that doesn't count. Add the picture as an attachment in your email. Subject line, please use your first and last name so I can tell who this is from. And then write in there assignment 1. Send it to me, Josiah Henderson at ofy.org. So let's get into why the zero exponent rule works and why the negative exponent rule works. Now, yesterday I showed you these two rules. Everything to the 0 power is 1, and how we can convert negative exponents and make them positive by switching their location, changing their position, like we see right here. So where does this come from? So to show you this, I want to start with kind of an example. So let's start with a low number like 2, and I'm going to do powers of 2. So let's do 2 to the first power, 2 to the second power, 2 to the third, and 2 to the fourth power. Now I want to actually simplify these all the way and see like what are these powers equal to. So 2 to the first power, recall that anything to the first power is just itself. It's just the base. This is 1, or I'm sorry, this is the number 2 itself. Okay, so 2 to the second power would be 2 times 2, so that's 4. 2 to the third power is 2 times 2 times 2, that's 8. 2 to the fourth power gets us 16. And you could keep going, right? Like you could have 2 to the fifth and figure out what that is, and 2 to the sixth. But I'm going to stop here for this demonstration. So we see that these are 2, 4, 8, 16. So my question to you is, what is the pattern as the powers are increasing? So basically, what's the pattern from left to right? Do you see a pattern? How do I go from 2 to 4? How do I go from 4 to 8? How do I go from 8 to 16? By multiplying something. It's times 2 each time, right? So 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. The reason this is because we're doing powers of 2. So every time we make this exponent bigger, like at the top row, 1, 2, 3, 4, the exponents, every time we increase that exponent, we're just throwing in another 2 into our math problem. We're just multiplying an extra 2 into the math problem. So let's talk about the 0 exponent. So in my list of powers, this would go right here, 2 to the 0. See that? My exponents are decreasing if you look at it from right to left. 4, 3, 2, 1, 0. And while we're at it, let's not stop there. Let's put in the negative exponents as well. The next one would be 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, and 2 to the negative 4. I'm going to stop there because it matches what I have on my right side of the screen as well, right? 2 to the 4, 2 to the negative 4. So if my pattern to go from left to right, like we talked about a minute ago, is times 2, right? To get me up to the next like level each time, the next term. What's my pattern to go the opposite direction? So to go from 16 to 8, here, let me change my color for this. To go from 16 to 8, you're dividing by 2. Does that work for all of them? So I'm going to write this, divide by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. And then we need to continue that pattern leftward to find out 0 power and negative exponents. So 2 divided by 2 is 1, right? 2, let me do that on the side. 2 over 2. Remember, anything divided by itself is 1. And continue the pattern. 1 divided by 2. 1 divided by 2. Look at that, 1/2. And if you continue this pattern, a half divided by 2 is a fourth. And if I continued it, it would be 1/8 and 1/16. A couple things I want you to see is look at the symmetry on the left and the right of the screen. Kind of symmetry. We have 1 right in the middle, and then we've got 1 over 2 and 2. 1 over 4, 4. 1 over 8, 8. And 1 over 16, 16. And it would continue like the same way on both sides. So the next power would be 2 to the 5th, and that would be 32. And 2 to the negative 5th is 1 over 32. And it just keeps going forever. So this is what powers are doing, or really, I guess, what powers are symbolizing for us is how many 2's do we multiply by? And if we have negative exponents, it symbolizes dividing by 2's. So here it's like we're kind of dividing by another 2 each time to go leftward. And this is where the exponent rules come from. So this is why if you look at the middle, any number we pick, I did this list with 2's. But if we had done it with 3's or powers of 4 or 5 or whatever, anytime we go from the first power to the 0 power, we're dividing by the base. So it's basically always going to be the base divided by the base, and that gives you 1. So anything to the 0 power is 1 for that 0 exponent rule. And the negative exponents, that's why it flips and changes positions. It goes from being like this, for example, top right corner, quick example. If we had like a to the negative 4, it's not it is flipping, but really what's happening is we're dividing by a 4 times. It's supposed to be a 4. 1 over a to the 4th. So it switches positions. It moves down, so to speak. I hope that's helpful. That's why those rules exist. That's where they come from. So now let's look at the new material, power to a power rule. So this is new. Didn't see this yesterday yet. Now, yesterday we looked at the product rule and the division or quotient rule, and then we worked with negative exponents and 0 exponents. Here we go. What happens when we raise a power to a power? Meaning if we have an exponent raised to its exponent. Here's what that looks like. 2 to the 4th power to the 3rd power. Before we formalize this, let's just try solving it with our definitions. And here's what I mean by that. So we can do this actually two different ways, but let's do it. Let's start with this way. So notice that we have a parentheses to the third power. So look to the right with me here for a second. Parentheses to the third power. Pretend for a second we don't really care what's inside the parentheses, okay? We just know that we have three groups of these parentheses. What does that look like? Okay, I'm gonna expand that and write it out. So here's my first parentheses, here's the second, and here's the third. I've expanded the third power out. Now let's kind of circle back to what was inside the parentheses after all. It's 2 to the fourth, right? So let me go ahead and fill in each of my parentheses with 2 to the fourth. And then I'm going to expand each one of those. So 2 to the fourth, that's 4 2's. There's the first one. Second one. Okay, so how many total 2's do we have here? Let's regroup. 2 to the what power should this be equal to? How many total 2's? 12 if you count them all up. So our answer is 2 to the 12th power. And this is how I found it just using the definition, just by expanding out the exponents and then regrouping. And like yesterday, I want you to look at those exponents that we started with, a 4 and a 3. And where did we end? With a 12, right? What's the relationship between 4, 3, and 12? It's multiplying. We multiplied 3 times 4, and that makes it 12. And that is the power to a power rule, the exponent raised to an exponent rule. We'll write that out in just a moment. Let's try that here. So based on the last example, what it looks like we should do to shortcut it is multiply the outside power to that inside power. So that means x to the fifth to the third power should become what? X to the 15th power. 3 times 5, 15. Let's try it here. A to the negative 2 to the fourth. We know we need to multiply the outside power to the inside. A to the negative 8th power. And let's finish this properly. We know that a negative exponent means change position. So I'm going to do that. It becomes 1 over a to the 8th, like that. Now we're done. What if more than one number is in the parentheses? Okay, so here we have three terms. 4, x to the fifth, y to the third. Those are our three terms, and they're all being raised to the second power on the outside. How we deal with this is we treat what we do is everything inside the parentheses should be raised to that second power. So let's start from left to right. Remember the 4, the whole number 4 there doesn't have an exponent, does it? But we saw yesterday that a number without an exponent is equal to that base with the first power. So I'm going to add in a 1 power for the 4 that we see, like this. Now we want to use the same rule we've been using with the power to a power rule, which is multiply the outside to all those inside exponents. So let's see what that looks like. We should have 4 to the second, because 1 times 2. X to the 10th, because 5 times 2. And y to the 6th, 3 times 2. We can simplify this a little bit because I can figure out what 4 to the second power is. 4 times 4 is 16. X to the 10th, y to the 6th. And we're done. So the takeaway here is if there's more than one number or term being raised to an outside power like this problem was, I want you to remember everything in there gets that outside power. Everything. Even the whole number like 4 got raised to the second power. See? 4 turned into 16. 4 squared, 4 to the second power. So here's our power to a power rule more formalized. A to the B power raised to the C power is equal to A to the B times C power. What happened is the C multiplied to the B. Whatever those numbers are, they get multiplied. So for any number A, B, and C, this is how power to a power works. Another example. And I am kind of mixing together lots of the different rules we've seen. So it's not just power to a power here. So I see 6 times x to the negative 1, y to the 5th, all raised to the 2nd, and then it's divided by 3, x to the 4th, y to the 3rd. So let's deal with that power to a power on top, because that's kind of complicated looking. And then maybe we can do some canceling and clean up this overall fraction. So what did we just learn? We saw that everything in the parentheses needs to get that outside power. So I'm going to put in a 1 here for my 6 because it doesn't have any exponent to start with. The other ones have some exponent. Now I'm going to multiply 2 to each exponent we see.
Oh, yes.
All right, so what's left on top now? We go at 6 to the second power, x to the negative 2 power, y to the 10th power. And in the denominator, we didn't do anything, did we? So make sure to bring all that over. 3, x to the 4th, y to the 3rd. Now, let's clean everything up one part at a time. So I like to do the whole numbers and then the x's and then the y's, like one type of like term at a time. All right, so on top, 6 to the second power, that is 36, 6 times 6. And below, we still got that 3 hanging out. We'll come back to that later. X's. I've got x to the negative 2. What do I do with negative exponents again? They need to change position. So x to the negative 2 moves down here. And now it's a positive 2. And there already was x to the 4th down below, right? So I'm going to make sure to move that down 2 in my work. We'll combine those in a second. Y to the 10th over y to the 3rd. The rule is top minus bottom. So that will be 10 minus 3, which is y to the 7th. If you're wondering where to put it, let's say that you figured out that it was y to the 7th, but you might have put it in the denominator. I want you to look at the y's again with me. Where is it heavier in y's? Meaning like top or bottom? Does it have more y's on top or on bottom? So you can tell that there's more on top, right? There's 10 on top, 3 on the bottom. So once we cancel, because remember, that's what's happening when we use our quotient rule. When we cancel, where should there be y's left over? Should be on top because there's more up there to start with, right? So those 3 on the bottom go away, 7 are left over on top, and that's why I have mine in the numerator in my answer. All right, so let's finish this up. 36 over 3, well, that's 36 divided by 3, which is 12. Times y to the 7. Notice that there's no y's to cancel with below. All right, and then x to the 2nd times x to the 4th left over in the denominator. That's x to the 6th power. And we're finally done. So here's our answer. Here's our simplified version. Another one. I see two factors, two large terms, I guess, two parentheses. We've got this one, 5a to the 6th, b, c to the 10th times a 8a to the 2nd, b, c to the 3rd, all to the negative 2 power. So So that negative 2 power applies just to this parentheses, the one on the right. Let's start by, I guess, handing out that negative 2 power to all those exponents on the right. Oh, and I missed one. Look at that. B. B has a 1 exponent. Whether or not it came with it, we need to add it in there and then multiply the 2 to that as well. So what does that look like? It's 8 to the negative 2, A to the negative 4, B to the negative 2, and C to the negative 6. Okay. Now, honestly, you could convert all these negative exponents to like being in the denominator. We could flip them, right? Change position. But it actually might be faster to just use the product rule. And here's what I mean. We'll end with the 5 and the 8. Let's end with the whole numbers. Let's look at the A, B, and C first. If you pretend that this didn't have anything except A's, let's just focus on those. A to the 6 times A to the negative 4. Off to the side here. Well, here, this is like the very first type of exponent problem we did yesterday's lesson. So what do we do with a product of 2 powers? They can add the exponents. Remember, this is 6 A's, and then we have a negative 4 A's, so to speak. Remember, this is dividing by A 4 times. Negative 4 exponent. So we add the powers together. 6 minus 4, well, that's 2, right? So what we left with is A to the second. Now the B's. I'll do that on the side. B times B to the negative 2. We can put a 1 in here for the single B. 1 minus 2 is negative 1. So this is B to the negative 1. C's. We got C to the 10 times C to the negative 6. We add those together. C to the 4. Okay, we're almost done. We have to deal with the 5 and the 8 to the negative 2. For this one, I think we do have to convert it. Let's see why. So 5 times 8 to the negative 2. So these aren't the same base, right? They're not going to combine together. So because of that, we have to convert this 8 to the negative 2. So it's 5 over 8 to the 2. And let's simplify that. So that's 64. 5 over 64. So if we were to multiply this to our other running tally for the answer, it's 5 times all the other stuff over 64. And last thing is that B is negative to the negative 1 power. So let's fix that. Here's our final answer. 5A to the second, C to the fourth, 64 times B. All right, here's another one. It's kind of like a division inside the parentheses, all being raised to the 5th power. So everything inside the parentheses, remember, needs to get that 5th power applied to it. Everything. Stuff on top and on the bottom. So there's actually 2 ways we could do this problem. And for most of these today, there's more than one way to like start it. As long as we use our different exponent rules and you start canceling and simplifying, you should get the same answer no matter how you approach it. I'm going to show you both ways. So here's way 1, approach 1, and then we'll do approach 2. So approach 1 is let's simplify everything we can inside the parentheses first. So here's how it starts. Haven't changed anything. Pretend that it's just the fraction and no fifth power on the outside. Pretend that's gone. So simplify what's inside that parentheses. So it's 3 e to the fourth over e to the second. That's e to the second on top because 4 minus 2. And then for my f's, there's one f in the denominator because 2 minus 3 is negative 1. So f to the negative 1. And then remember, negative 1 means move it down to the first power. So there's our division or fraction inside the parentheses. And now we'll raise it to the fifth power. So that's 3 to the fifth, e to the 10th over f to the fifth. Okay, now on the right, we'll do way 2 or approach. Approach 2, a different way to do this problem. Okay, so we could start by passing out that 5 to everything first and then start canceling. So I'll start with the beginning. Okay, like this. So start by multiplying all the powers by 5. So we have 3 to the fifth, e to the 20, f to the 10, over e to the 10, f to the 15. Okay, so 3 to the fifth. I actually didn't do that last time. Let's see what that is. 243. So 3 to the fifth is 243. I should have done that on the left. I just forgot to do the whole number. 243. Now for the e's. Remember, it's top minus bottom. So 20 minus 10, e to the 10th. And then f is top minus bottom again, 10 minus 15. That's negative 5. The negative means put it in the bottom, put it in the denominator. F to the fifth. Notice that my answers are the same, but we did it in a different way. I think I like way 1 better, but you can use either as long as you use your rules and keep going until you can't do any more. You should get the same answer. Okay, if you haven't added me on remind.com yet, it's time to do it right now. I want you to text this code to this phone number. So you're going to open up your phone, you're going to do a new message, compose new message. For the phone number, type in 81010. That's it. That's all you need. And then this is the message in your text. @6GGDDE. Hit send, and then you will be added to my Remind group. You and I can communicate faster, and I can send you announcements about the class. And you can ask me for help on any assignment or question about the class. All right, now for your homework. Log into Admentum. Okay, you've been added to Math 2, so you'll see it there in your list of classes when you first get logged in. So obviously open Math 2, go to see all activities. Okay, and then go to Unit 1, expand Unit 1. And then the very first lesson is called Properties of Exponents. I want you to just do the mastery test, okay? Do the mastery test. It'll be 5 questions. I want to see how you do. And if you need to take it again, you can. It's no worries. But I want you to try now on your own. And then we'll talk about it next week, how it goes. Have a good weekend. Make sure to get your mastery test done. Add me on Remind. And if you haven't done it, you need to do those 6 problems that I gave you to do on paper from the last lesson. Bye.